This is Unit 3, Matter. Lesson 1, Types of Matter. Practice your skills. 1. Expressed in the correct number of significant figures, the sum of two masses is 445.2 grams. Which two masses produce this answer? In order to add numbers together, I cannot be more precise than the least precise measurement. And when I add or subtract, the least precise is the least number of decimal places. Therefore, because I only have one decimal place in this answer, my values that I added together can't have more than one decimal place. Therefore, this answer choice is the only one that meets that criteria. 2. A student determined in the laboratory that 1 mole of KMnO4 had a mass of 171.54 grams. The mass of 1 mole of KMnO4 in an accepted chemistry reference is 158.04 grams. What is the percent error of the mass of 1 mole of KMnO4 as determined by the student? So here, determined is going to be the same thing as measured. So if the student determined the value to be 171.54 grams, that'll go on my measured value. From table T, I have this formula. The accepted value is 158.04 grams. So I'll take 171.54 minus 158 and divide that by 158.04 grams. And then multiply that whole thing times 100. So when you do that math, you'll get 8.54%. Check your understanding. I did this in class, so make sure you have this completely filled out with all those details. Practice your skills. So classify each of the following. Actually, I'm not going to go through each one of these. I'm just going to give you a chance to check your work. Again, recall that aqueous means mixed with water. So here, M stands for mixture, HO stands for homogeneous, HE stands for heterogeneous, C stands for compound, and E stands for element, with PS being pure substance. The trickiest one, I think, in this one is usually the sugar. Because there is only one thing here, it's only sugar. That's what makes it a pure substance. There's no water, there's no salt, there's nothing else here. Therefore, it's a pure substance. Even though there's three elements together, the definition of a compound is three or more elements chemically combined. And because I wrote them all connected together, that means they've been chemically combined. Yeah, this can be green. So make sure you look at these answers. Change the color. Okay. Let me check if there's anything else here. Okay, here's the regions practice. Actually, I'm not going to talk through each one of these. I left some notes. So hopefully my notes are clear. Actually, they're not very clear at all. So here, number 1, which statement is an identifying characteristic of a mixture? A mixture is two or more different substances. Therefore, I can't have a single element. A mixture can be separated by physical means. That's the definition of a mixture. And a mixture does not have a definite composition. It has a varying composition. And a mixture can be homogeneous or heterogeneous. So the only true statement is number 2. 2, different samples decompose. So if they decompose, that means they can break down, which means it's a compound when heated. If only one of the samples is soluble in water, that means they have different properties. Therefore, my 2 different samples may both be compounds, but they're 2 different compounds because they both have different properties. If only one is soluble in water, that means the other one is not. So that means they can't be elements because they can break down, and they can't be the same compound because they have 2 different compositions or 2 different properties. 3, matter is composed of 2 or more different elements when it's chemically combined in a fixed proportion. So that is the definition of a compound. So that's basically the definition of a compound. So that means it's not a mixture because they have varying proportions, and an element has only one element. So it wouldn't have 2 or more. 4, a compound differs from an element in that a compound can be decomposed by a chemical reaction. So because elements and compounds are both pure substances, that means they're both homogeneous, they both have definite compositions, and they both have definite properties. So melting point is a physical property. So these 3 things are all characteristic of both elements and compounds. So the only thing difference is that compounds can be decomposed by a chemical reaction and elements cannot. 5, a compound differs from a mixture in that a compound always has a homogeneous composition. So a compound could have more than 2 elements. It could just be 2 elements, or, in fact, compounds will never have a heterogeneous composition. They're always homogeneous. A heterogeneous material may be, of these words, only a mixture, because a pure substance is an element or a compound, and pure substances are always homogeneous. So that goes with pure substance here, which must be a mixture of a substance. So solids, liquids, gases are always pure substances. So that means they're not mixtures. A solution is aqueous, which means it's mixed with water. So a solution is always a mixture. Which substance can decompose by chemical means? So that means I'm looking for a compound. So this is why you had to memorize those elements, because now I can easily recognize aluminum as an element, silicon is an element, and xenon are all elements, but octane is not. This is actually a compound. And if you didn't have your elements memorized, you wouldn't know that very quickly. Which substance can be decomposed by chemical means? So this is the same rationale as above. So ammonia is the only thing that's not an element, while the rest of these are all elements that you had memorized. 10. Which terms are used to identify pure substances? So pure substances are elements and compounds. 11. Which substance cannot be broken down by chemical reaction? Which means I'm looking for an element. So again, having them all memorized will make it easy to spot that argon is the only element here, while ammonium, methane, and water are all compounds. 12. Two substances A and Z are to be identified. Substance A cannot be broken down by a chemical change. Therefore, we're looking for an element, or that defines it as an element. Substance Z can be broken down by a chemical change, which defines it as a compound. So what can be concluded about these substances? So we know they're different because they have different properties. So they both can't be the same thing. Doesn't matter what they are, they're not the same thing. And we already identified substance A as an element based on its definition, and substance Z as a compound. So 3 is the best choice. 4 has them backwards. 13 is a commonly missed question. So I see this one wrong all the time. So you can star this one. Tetrachloromethane, CCl4, is classified as. So it doesn't matter if you know what this is. This is not mixed with anything. So this is just a chemical compound. I have only that, which means it's a compound because I have them chemically combined. And so the fixed proportion is the definition of a compound. So I could have crossed out 2 because this is not the definition of a compound. It's not a proportion that varies. And then I crossed these ones out because it's the only thing by itself. It's not mixed with anything. And this is the commonly mixed choice. We know that the proportion, you usually pick it, it's a mixture, but it's not a mixture because this is all by itself. For 14, the table shows the mass and volume of 4 different samples of a substance at the same temperature and pressure. So which 2 samples could consist of the same substance? So it ends up being A and C, and the way that I'm going to do that is calculate the densities for each of the samples, and the samples with the same densities are the same because density is a property that is the same for all samples of the same substance. So if you go through the calculations, you'll see that this one and this one calculate to be the same.